Okay, in this problem where it's asking how many grams of BaCO3 could be made from reacting 500 mils of 1.20 molar Na2CO3 with excess BaNO3 solution. Now this part here is not really part of the problem. All it's telling you is that there's enough BaNO3 in the solution for us to react with completely. So it tells you that this is not the limiting reagent. So, or the amount of BaCO3 that we're getting here is going to depend entirely on the amount of sodium carbonate that we have in the solution. Now, as far as what we start with, usually as a rule of thumb, what you have the most information about is usually what you should start with. The other clue is given by the question. It says how many grams of BaCO3. So that tells us that we need B, how many grams. So that's going to be B, or what I want, and this is going to be what I'm going to start with, or A, Na2CO3. Now, because it's a stoichiometry type problem, I like to use my modified flowchart, which is just QA is moles of A, moles of B, and gives Q of B. Now, these Q's here are just quantities. It doesn't matter what those are. But the point is that the first thing we want to do is find out the number of moles of what we start with. Then we find out the number of moles of what we want. And then we get the quantity of what we want. Now, in order to get moles, what I'm going to do is use my little equation here for about molarity. And molarity is equal to moles over volume in liters. What that means is that if I want moles, I'm going to have to take molarity and multiply it by the volume in liters. So it doesn't really matter what I start with here. I have a molarity, I have a volume. I'm going to multiply them. It doesn't matter which one I put first. But I'm going to go ahead and put the molarity first. And that's going to be 1.20 moles of A per liter. And I'm going to multiply that now by the volume. Now the volume here is in milliliters, is 500 milliliters. Now as you can see, the liters and the milliliters aren't going to cancel, so what I'm going to have to do is find a way to get rid of them. Remember, my target is to get moles of A first, so what I'll do is I will put liters here and I'll put milliliters here. Now I know that these liters here will cancel, these milliliters will cancel, but the relationship here is that 1 liter is equal to 1,000 mils. So now at this point I have moles of A, and that was my first target. Now I need moles of B, so I know moles of A is going to go on the bottom, and I know that moles of B is what's going to go on top. Now the relationship here is going to be gained by looking at the equation. Now A, as we said, is Na2CO3, so that's 1 mole there. And we've got moles of B. B is BaCO3, that's 1 mole as well. So we can see the relationship is 1 mole of that to 1 mole of that. At this point, what we've got is moles of B. As you can see, everything else is cancelled. And what we're looking for here is grams of B. So I'm looking for moles. I want the quantity. The quantity is grams. So in order to get that, I know the moles of B are going to have to cancel out. And I'm going to be left with grams of B. And that's what I want. So you can see the moles of B will cancel. Now the relationship here is going to be the molecular weight. We know that 1 mole is equal to the molecular weight of B, which is given as 197.34 grams. So you can see that when we multiply all this out, all we're going to be left with is grams of B, which is how we're getting our answer. Now for significant figures, looks like pretty much everything here has 3 significant figures, so the answer is going to pop out to 3 significant figures as well.